both the quiz that I want you to take this week from 6364, what do they want you to know by the end of these two sections, and also the test, what do they want you to be able to do from this section, from this. So, first of all, what if we just work backwards? Like instead of me giving you an angle from the unit circle, what if I give you a value from the unit circle and I ask you to tell me what the angle is? And there's kind of two ways they can do that. And so I picked these questions just because there are a couple questions like this on your quiz for this week that says, suppose theta is located in quadrant 2 and cosine of that angle is negative square root of 3 over 2. What is theta in degrees? Or they could ask, what is theta in radians? Well, special angles in quadrant 2, right? If you know your unit circle, you only have 3 options. It's either going to be, I know radians way better than I know degrees, but this would be 2 pi thirds, 3 pi fourths, 5 pi sixths, right? So if they tell you what quadrant you're in, you have a 1 in 3 shot. Hopefully you're not guessing. You want to be able to tell me which one of those has a cosine, or know that cosine means x of negative square root of 3 over 2. And so for those of you that haven't done unit circle before, if this was on a quiz, you don't have that unit circle in your notes to look at. And so it's where you've got to be able to kind of reproduce it. And so I don't know how you do it. I don't know how you people that do the unit circle do it. For me, I always do the first quadrant, and then I kind of flip them over of which ones go together. So in the first quadrant, remember I gave you that little shortcut. But if you start at the top and go down, it's like 1, 2, 3, and then you go back up 3, 2, 1. And then over 2. And then we take the square roots of all the top numbers. And then you just put them with the ones that go with it. And so since this one has an x value of square root of 3 over 2, then that tells me that this one right here at the bottom is the point negative square root of 3 over 2, 1/2. And so it's this angle right here, which in radians is 5 pi 6. In degrees, that's 30-degree increments. So that would be 30, 60, 90, 120, 150, 150 degrees. If you know your unit circle, there's not a whole lot of work to show with that. If you draw out your unit circle, you're just kind of looking at it, but it's a lot of thinking about where am I, what's happening here. The ones on your homework are harder than this, right? This is like what's on your quiz. They tell you what quadrant you're in, so you can kind of deduce down which quadrant you're in. The ones that are in your homework from this, they kind of give you a bigger range for it. And so like look at number 2. It says, suppose theta is located in a circle from 0 to 2 pi, and tangent equals negative 1. What is theta in radians? And so this one is harder because they're telling you to go around the whole circle. So tangent equals negative 1. What does that tell me about my ordered pair? Yeah, they're the same but opposite signs, right? But they're the same number because that's the only way we can get 1. And which which angle is the one that gives me the same order pair all the way around? Force. So like pi force, 3 pi force, 5 pi force, 7 pi force. Again, one strategy that people have when they do this, when they have a quiz or a test, is they just make the whole unit circle on their quiz. And that's okay if you want to do it, or if you just want to look at one question at a time. But remember that the force are square root of 2 over 2, square root of 2 over 2. And then you just change the sign. So in quadrant 2, that would be negative square root of 2 over 2, square root of 2 over 2. Would that angle give me a tangent of negative 1? Because if I took y over x, they would cancel out to 1, but one's positive and one's negative, which means that would be an answer of 3 pi fourths. Is that the only angle that gives me a tangent of negative 1? Yeah, over here, remember that it switches, that now this is positive square root of 2, this is negative square root of 2. So because they don't say just in quadrant 2, they tell me on the whole circle. There's another one over here. They repeat themselves that this is also tangent of negative 1, so that would also be 7 pi fourths. So just be aware that our functions are going to repeat themselves over and over again. And we really could keep going. If it said from 0 to 4 pi, we could add 2 pi and keep going. I'm not going to get to there yet. But just know that sometimes you can have more than one answer. Sometimes they'll just tell you in this specific quadrant which answer is it going to be. So because our answers repeat themselves, before we jump into graphs, I want to talk about what this means for us in terms of domain and range, and in terms of a special word that we talk about with radians. So there's a lot of writing on this. Good thing for you because I wrote it out for you, and you just have to kind of fill it in. Sine and cosine. Sine and cosine are really the only two functions I'm going to focus on today in terms of the graph and understanding their domain and range. And then when we get into section 6.5, we'll talk about all the graphs that you need to know and all the other formal stuff for it. But for sine and cosine, why do I like to start with those? Because remember that if you have a point on the unit circle, then the x-coordinate is the same as your cosine value, and the y-coordinate is the same as your sine value. And so we don't really need to draw this whole unit circle again, but think about that going around that circle. It's a continuous circle, and although we only pick nice angles, right, we pick 30 degrees, 60 degrees, 45 degrees, that's a continuous circle, which means that you really could pick any angle that you want, and that's where we can use our calculator to find like the sine of 33 degrees and the sine of 42.5 degrees. So we are going to say that the domain of sine and cosine is all real numbers. You can pick anything you want. So remember to write the domain. We're going to say negative infinity to infinity. But think about on that unit circle, and I guess I'm just going to draw this in here. For those ordered pairs, think about what's the biggest and the smallest values that x and y ever get to be, right? And I think they're going to be at like these points here, right? This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0, and 0, negative 1. Everything in between here, right? Starting here, the x is 1. The x goes up to 0, down to negative 1, back to 0, back to 1. It just keeps repeating that cycle, which means the highest value that you ever get for x or for cosine is 1. Right? Square root of 3 over 2 is less than 1. Square root of 2 over 2 is less than 1. No matter what you type in your calculator, the sine or cosine is never going to get bigger than 1 because it never gets bigger than 1 on the circle. And the same thing with the y value. The y value starts at 0, it goes up to 1, back to 0, down to negative 1, and it just circulates in that pattern. And so the range, the y values for both sine and cosine are stuck between negative 1 and 1. And all I did there was kind of change my y's to sine and x to cosine in those underneath there. So even if you took like the sine of 1,000,000 degrees or 1,000,000 radians, the outcome would still be in between negative 1 and 1, no matter how big of an angle you get. And that's because we can just keep finding coterminal angles. I could add 2 pi if I started right here. I could add 2 pi, it's going to be the same value, and add 2 pi again, and add 2 pi again. And so we've already talked about those are called coterminal angles. They also want you to know that they're also called periodic functions, meaning that they repeat themselves. And on the next slide, I kind of define that for you. But it means no matter what multiple of 2 pi that you add to your sine function, you're always going to get back that same y value. And when we talk about the graphs of this, you're going to see they just repeat themselves over and over and over again. So on the next slide here, let's just look there. So here's the definition of a periodic function, and different functions have different lengths of periods, but it says a function is periodic if there exists a positive r, that means a real number. If there exists a positive real number c, such that when you add c c to the function, you get back the same value. So no matter what, like whatever c is, when you add that to the function, you just get back the exact same value. So what we want to talk about is what is that value for sine and cosine that get us back to where we started? And we've already talked about that in terms of coterminal angles of if I start here at 0, what do I add to get back to 0? Well, I have to go all the way around the circle. And to go all around the circle, what am I adding? 2 pi. So we say that the period for sine and cosine, how long does it take back to get where I started, is 2 pi. What?
Like, except for the end, when it kind of creeps in. That's pretty good.
Oh, I just screwed up. Should have mentioned it. So we kind of talked about this yesterday with or Friday with what you did on 12 and 15. I told you you could just add or subtract 2 pi. But that means because we can add 2 pi and get back to where we started, we can say we know the sine of pi is the same as the sine of 3 pi, which is the same as the sine of 5 pi, which is the same as the sine of 7 pi, which is the same as the sine of 99 pi. Would that be true? No? Yeah? It's going to be odd, right? Every odd one. I just add 2 pi. I don't have to say sine of 99 pi. What does it equal? Well, go back to the one you know. What is the ordered pair at pi? Pi is over here. -1, 0. And sine is which one? Sine is y. So I can say I know all of these equal 0. So that's part of the reason understanding that the period of sine and cosine is 2 pi. The other reason that's important is when we start graphing these, we want to see when does it start repeating itself, because it is going to start repeating itself. Okay, the other thing that I want to talk about is even and odd functions. We talked about even and odd functions last semester in terms of algebraic functions. An even function is a function that's like x squared, like it's symmetric with the y-axis. It's the same on both sides. An odd function is like x cubed, where it's the opposite. It's symmetric with the origin. Well, trig functions are also either even or odd. And if you know them, it makes things really easier to evaluate. You have to think about it so much. So these two functions are even. Maybe I should have broken it up like that. So think about x squared. X squared is an even function because when you plug in a negative, you get back the same thing that you started with, right? -2 squared is the same as +2 squared. Cosine and its reciprocal secant are the only two even functions, which means no matter what negative you plug in, you get the same thing as if it was a positive. And I'm going to show you how to do that down here, like what that means for us. The rest of these functions are odd, like x cubed. X cubed is an odd function, so when I plug in a negative, I actually get back a negative answer. So when I plug in a negative angle, I get a negative trig function. The majority of your homework today says use negative angle rules to help you. That's what it means. They're talking about even and odd functions. So you have to use these rules? No, you could actually just figure out where that negative angle is and work it out. But the idea is if you know the rule, if you know this, you can compute this maybe without having to think so much. So like when it says sine of -90 degrees, yes, you could just think about where is -90 degrees. Or if you're thinking about odd functions, then that's the same as saying negative sine of 90 degrees, because sine of a negative angle equals the negative sine of that function. And what is the ordered pair at 90 degrees? Up here. Right, 0 on the x, 1 on the y, and which one is sine? Y, but it's negative the y value, which is 1. Which is the same thing you would have got if you would have just said -90s down here. You see what I'm saying? Like you see how you don't have to use this rule? But it's supposed to be if you just know your unit circle values. The same thing's true for this one. Cosine of -3/4. Cosine is even, which means this negative means nothing. It's the same as if I took the cosine of +3/4. And people really struggle with negative angles. And so if you know this rule, and you know cosine's even, you can just say, oh, 3 pi force is where? Less than pi. And what's the ordered pair going to be for 3 pi force? And cosine is which one? Negative square root of 2 over 2. So again, it's why knowing your unit circle is helpful. Going in those rules is supposed to be helpful. You can always just add 2 pi or 360 degrees and make it a positive angle and get the same answer. Okay? Alright, the other thing, and I was going to skip over this until 6.5, but on your quiz on Friday, there is a problem that they want you to graph. So we need to make sure we talk about graphs before we get to 6.5. We're not going to do anything crazy right now, but I just want you to think about the period and think about the shape of these two graphs. That's kind of what we want to talk about right now. Those of you that took pre-cal, these graphs can get really crazy really quickly, but we're not doing that until 6.5. So for those of you that haven't graphed sine before, we just want to start and think about what we could pick for x and to get the y values. And this first one, I'm going to pick a lot of points just to kind of show you that it's taking the unit circle and putting it on the xy plane. But notice that this is going to be your angle. This is going to be the number that you get back. So we're going to just make a nice xy chart here. And then let's just make a coordinate plane. No circle here. We're going to graph this just like we've always graphed lines here. So I'm just going to make a nice little graph here. Okay? And because we've already talked about that, we know the period of pi, we know the period of sine is 2 pi. That means after we get to 2 pi, it's just going to repeat itself. And again, I want to show you that that's true. So I'm going to, let's just wait. I'm just going to pick some angles here. I'm going to pick 0 first. And again, we can use our unit circle to help us, or you can use your calculator right now if you want, but know that sometimes you're not going to have a calculator. If I'm talking about my unit circle at 0, remember the ordered pair is 1, 0, so the sign of 0 is 0. I like to call these key points, okay? So we could pick a lot of things here. We could pick pi thirds, we could pick pi fourths, we could pick pi sixths. I like to pick the high and the low points. And if you think about the high and the low points of my unit circle, they're the ones up here. So I like to pick those. So let's pick pi halves. Let's pick pi. Let's pick 3 pi halves. And then let's go back to 0 around would be 2 pi. And again, those of you that haven't done this before, use those points to help you. Pi halves is the ordered pair 0, 1, and we know sine is the y value, so that's going to give me a 1. At pi, the y goes back to 0. At 3 pi halves, that's 0, negative 1, so the y goes to negative 1. And then at 2 pi, it goes back to 0. And again, like I said, we could pick all the ones in between if we want. We could graph the square root of 3 over 2 and the square root of 2 over 2 and 1/2. We could graph all those, but these are nice points, all right? I call them key points. Your book calls them key points. They just mean nice points. What's going to happen if I kept going? All right? We don't normally graph a ton of this, but just to show you what periodic means. If I kept going more than 2 pi, right? So if I stopped at 2 pi and I went up here more, that would keep going to like 5 pi halves, and then that would be 3 pi. So you agree that these same values are just going to repeat themselves over and over again? That's what I mean by periodic. So you don't ever have to pick more than one period because it's just going to repeat itself, because this is still going to just go back to 1 and then back to 0. So let's make a little graph here. I tend to do this. Like I mark off 2 pi, and then I break it up in half. Half of 2 pi would be 1 pi. Then this would be pi halves and 3 pi halves. And again, this is the y-axis. This is the x-axis. So this has my angles on it. Normally when we label the x-axis, we label it 1, 2, 3, 4. But we want to use our angles, so that's why we're labeling it by the angles that we chose. Just because this is our first one, I'm going to add these extra ones here. I'm going to add 5 pi halves and 3 pi, just because I want to show you this whole periodic thing, and then we'll talk about the negatives. Yes. Because the sine of 2 pi, the sine of, the period of sine is 2 pi, unless we threw some number in there, which we're not doing right now. The other thing to remember is the y values are not going to get bigger than 1 or smaller than -1. So you don't have to make a ton of numbers up here. Like I'm just going to put 1 and try to sort of symmetrically put a -1 down there. And just like all the other functions that we've made, this has smooth, rounded curves, not sharp, jagged edges. So we could pick a lot of points here, but I only picked these points. So let's graph what we have. At 0, I have 0. At pi halves, it goes up to 1. At pi, it goes back to 0. Then at 3 pi halves, it goes to -1. And then at 2 pi, it gets back to 0. So when you connect that smoothly, it should look something roughly like that. Those should be symmetrical if your points are evenly spaced. Here's what's important to know. One full period covers the highest and the lowest value of sine, and it covers all the values in between. So you can't say one period stops here because none of the values have been negative yet. So then you have to include all the negative values, and then when it gets back to 0. So this is one full period of sine. What's really cool about this is just this keeps repeating forever. So without even having to keep picking points, I know it's going to continue the pattern and go up to 1, down to 0, down to -1, back to 0. So I know this is going to go up to 1, down to 0. I'm out of room, but this would go back down, back up. And it's just going to continue this periodic function over and over and over and over. Normally, we like to say graph 2 periods. I usually graph a positive and a negative. So let's go back here and graph to -2 pi also, if you haven't already labeled that. -pi. The one's in the middle. This also shows the whole idea that a sine function is an odd function, because if it continues this pattern, right, it's got to go up and then down. So if we're going backwards here, do you agree that it makes sense that this side has to go down now? It's not going to go up because that doesn't keep the pattern, like the wave going. Or if you plugged in -pi halves, you would get -1, back to 0, back to 1, back to 0. So it just continues that pattern, which is what makes periodic functions so awesome, that you don't have to pick a ton of points. And actually what your book wants you to do is not have to pick any points. They want you to just know it, and hopefully eventually we'll feel pretty good about it. But right now, pick those points that give you 1s and 0s and -1. So let's graph cosine, and you're going to notice that cosine is going to look very similar to this. They're both these wave functions. They call it a sine wave and a cosine wave. The difference is just where they start, because think about when you plug in 0 for sine, you're going to get 0. And when you plug in 0 for cosine, you're not going to get that. So let's look at cosine, and then let's talk about what they're going to want you to do on your homework. So I'm going to pick those same points, only I'm just going to go from 0 to 2 pi. And for those of you that haven't taken pre-cal before, this is how I find my key points. The period is 2 pi. So you can always take half your period, so half of 2 pi is pi, and then half of it again will always give you those nice points, which for now will always be the ones on the x and the y axis. And again, you'll be expected to know this without a calculator. And the way you can do that is these points right here. But remember now that cosine is the x-coordinate on the unit circle. So I'm just going to go around and pull all the x values out. The cosine of 0 is 1, but the cosine of pi halves is 0. At pi, the x-coordinate or the cosine is -1. Then we go back to 0, but we haven't completed one full period until we get back to where we started, which for cosine is getting back to 1. So once you get back to 1, then you know you've completed one cycle, and you can just repeat the pattern. So I'm just going to go to 2 pi and -2 pi if you're okay with that. Really important when you're graphing trig functions that you label your axis. If you don't label that you're going by pi halves, I think you're going by 1. So it's really important that you show me something that you're labeling. Again, on my y-axis, I'm just going to go to 1 and -1. Big difference between sine and cosine. At the origin, sine starts at 0. Cosine starts up at 1 because cosine is the x-coordinate. So it starts up here, and then we kind of just repeat that pattern of it goes down to 0, then at pi it goes to -1, back to 0, back to 2 pi. And again, smooth, rounded edges, and be really careful at the end of this because this is not going to keep going up, right? If we kept going here, this is going to go down and it's just going to keep going that pattern. You don't have to show that, but don't show that arrow going up because it really should turn and come back down and just keep going over and over again. But that's what one full period of cosine looks like, starting at 1, ending at 1. Something else really important is thinking about that even function. Cosine is even like x squared, which means on the other side, on the negative side, it's going to be exactly the same. Because it's an even function, it's the same on both sides. So at -pi halves, it's back at 0. At -pi, it's down to 1. -3 pi halves, back to 0, and back up to 1. That would be 2 full periods of cosine. You can definitely see that they're similar to each other, but they start at different spots, so it's important to know that. Here's what you're expected to be able to do on your quiz on Friday. What if I add or subtract a number to sine or cosine? Because they're not just going to give you kind of sine or cosine, like that's it, sine or cosine. They want you to kind of combine that with transformation. So on the next slide here, I just said, remember to use key points to graph. That means pick points that give you nice numbers. For now, those are always going to be 0, pi halves, pi, 3 pi halves, and 2 pi. Later on, when we get into other stuff, section 6.5, we will have to think about what to do to get those points. But right now, those are the points you need to pick. But let's think back to our transformation rules. Like, look at the next slide. What if I said graph y equals 2 plus sine of x? What does adding a number to a function do to my graph? It moves it up or down. So when they add or subtract a number to your trig function, it's going to be that same wavy line. It's going to be the same angles that you graph. But what's going to be different is we're going to shift it up or down. And in this case, this means that it's going to move up 2 units. So all those same numbers that we got, we're going to have to add 2 to it. So normally, what's the biggest value that we get for sine? 1. If I add 2 to that, what's my biggest value I'm going to get now? 3, right? And so that's how you can kind of think about what your y values are going to be. So same xy chart every time right now. Well, the x part. My x part is always going to just go from 0 to 2 pi, and then I'm going to do the opposite or the same depending on the sine or cosine. So I'm going to do 0 to 2 pi, cut it in half, half again. And if you just memorize those numbers, 0, 1, 0, negative 1, 0, I'm okay with that. Or you can just think about it and then add 2 to it. So normally when we plug in sine of 0, we get 0. But 0 plus 2 means we're actually moving that up 2 units. You with me on that? When I plug in pi halves, right? Remember pi halves is up here. So that's 1. 1 plus 2 gives me 3. Pi sends me back to 0 plus 2 is 2. Be careful with your negatives. 3 pi halves gives me a negative 1 value, but negative 1 plus 2 is 1. And at 2 pi, I better end back where I started at 2. So you see how we've just added 2 to all those numbers that we got, which means if you can do that without actually making the chart, I'm okay with it, but the chart's not that bad to make. I don't think it says how much you have to make. Like, I think you just have to make 1 full period, so if you just want to do that, I'm okay with it. Yeah. I like 2 periods just to get practice doing it, but, so for me, I always do negative 2 pi to 2 pi. See what the back of the book does. I haven't even really done that. But pay attention to your numbers now. We need to go up to 3 now. We really don't even need any negative numbers because we moved up. Still should be that same smooth curve. We've just moved up. So let's see. At 0, it's moved up to 2. Then we're going to move up to 3. Then we're going to go back to 2. And then down to 1. And then back to 2. Does that look like that same sine curve? Kind of squished it in, but it goes up, back to 0, down to negative 1, back to 0. We've just moved it up 2 units. And remember that sine is odd, so to keep that pattern going, you got to go down first now. So now this one's going to go down to 1, back to 2, up to 3, back to 2. Oh, I really missed that 2 mark there. But sometimes what people think about is they just think about moving their x-axis up 2 units, right? So like this would be your new x-axis where it's like cut in half. I don't know if that makes any sense or not. That's the kind of question that's on your quiz on Friday. I'm not going to tell you which one it is or if it's adding or subtracting, but it's going to be a sine or a cosine function where you have to add or subtract a number to it. So I have one more with subtracting on it just to show you with cosine, and then that's it. And there's not that many problems today. There's a lot of notes to get to these problems. Questions on where I'm getting that? All right, so let's look at the next one. I put that one in front, and I put this one in back just to show you it's the same thing. It could be a negative 3 in front. But if it's something added or subtracted, then this means it's translating it up or down. And because it's minus, this means that it's moving down 3 units. So every value that we normally get, our 1s or 0s or negative 1s, we're going to subtract 3 from it. And remember, it's cosine, so you're talking about the x values. But again, I'm going to pick my same points every time today. Normally at cosine I get 1, right? Because that's over here at 0, the x-coordinate is 1. But 1 minus 3 gives me negative 2. At pi halves I get 0, and 0 minus 3 is negative 3. At pi, the x-coordinate is negative 1. Negative 1 minus 3 is negative 4. Then at 3 pi halves, I should go back up to 0 minus 3 is negative 3. And at 2 pi, I'm back to 1 minus 3 is negative 2. You've got to make sure those top and bottom numbers are the same if you've completed one period. Questions on where I'm getting those numbers? Do my math right? And again, notice on this one, because these are all negative, I don't even really need any numbers on my positive axis here. And again, notice I always label at least one number on my y-axis, because what if you were going to like 20 and you start labeling by 5s? I need to know what you're going by. If you don't label, I assume you're going by 1s. So if you ever go by something other than 1, you need to make sure that you label that. And again, I always do the positive side, and then I either do the same or flip it, depending on if it's cosine or sine. But at 0 now, I'm going to be at -2. At pi halves, I'm at -3. Then at pi, I'm at my lowest value, which is -4. Then I go back to -3, back to 2. -2, sorry. And again, notice my points weren't super great, but I made it curved, not pointed. It's very not good stuff. And cosine is even, so it's the same on this side. So I know here it's going to be at -3, and then back at -4, and then back at -3, and back up to 2. Definitely check your answers in the back just to see kind of how they did it, if they did it a little differently than me. I'm looking for your points and the shape correctly as I'm looking at those. So again, we'll do more with graphing later, but they throw that in here and it's on your quiz, so that's why I couldn't skip it, because I wanted to skip it until section 6.5, but not a bad way to start it. So your homework, make sure you pay attention to the directions on this, because I've changed them on some of them. It looks like a lot of stuff, but 18 and 19, just do what it says. But then 39 through 48, that should say times 3. I somehow lost the 3 there. So 39, 42, 45, 48. There are 4 problems there that are like our first 2 examples, where it says like, find if sine of theta equals 1/2, find theta. But they give you lots of weird intervals, like -4 pi to 4 pi. Like they give you really big intervals. So I want you to ignore what interval they give you, and I want you to give me just all the way around the circle, which means I think you should have 2 answers for every one of those. Maybe most of those. The one on your quiz is like, it says like in quadrant 3, but there weren't any like that, so I tried to make that as similar as possible. And then 56 and 58 are 2 graphing problems, just like the ones we just did, where you're either adding or subtracting a number to sine or cosine. I don't even remember what 18 and 19 are. Oh, 18 and 19 are just the negative angles, like using those negative things. So those are the 3 things we did today. If I give you the value, you give me the angle from the unit circle, the negative, like even odd functions, and the graphing. So kind of putting it all together, definitely practicing the unit circle. Tomorrow we'll move on to 6.4, which is talking about reference angles and more practice with it. 6.3 and 6.4 definitely go together. And probably I'm going to give you a worksheet this week, similar to one I give out in pre-cal, just to kind of summarize this all up together and before rushing on to other things, because this is kind of the foundation for all the rest of this class of understanding these special angles and the unit circle and the reference angles. So we're going to kind of take it slow this week and probably spend the rest of the week a couple days on 6.4, a worksheet, and then a quiz on Friday is my tentative plan.